Hello, dear students. I am Mayur Limbachia. Welcomes you all on my YouTube channel. Dear student, in today's lecture, we will solve the example number 1.2. The definition of 1.2 is already given on your screen. So let's just understand what parameter is given, and based on that parameter, we will solve the problem. So the parameter is given inside this particular example is how much positive and negative charge is there in a cup of water. So let me draw a cup of water. Suppose this is the cup of water and there is a water inside this cup. So to calculate how much positive and negative charge present inside that cup of water, first we have to assume the mass of the water. So let me assuming mass of the water inside this cup, inside the cup, m is equal to m is equal to 250 gram. Okay, so I have assumed the mass of the water which is present inside this cup is 250 gram. Now we already know that molecular mass of the H2O water is 18 gram per mole. How can we calculate that? So the calculation is given here. If you can see, we have a two atom of hydrogen and one atom of oxygen. Hydrogen have a atomic mass number 1 and oxygen have a atomic mass number 16. So 2 into 1 plus 1 into 16. That's why if we add these two numbers, we will have 18 gram per mole. So let's just use this information that molecular mass of water is water is 18 gram per mole. And dear students, we also knew that in one mole number of atom present is Na is equal to 6.022 into 10 raised to minus 20, sorry, plus 23. So this is the Avogadro number. Now if we use this information, now we can easily calculate the problem, or we can easily solve the problem. So dear student, can I use the rule of 3? Yes, I can use the rule of 3 to solve this problem. So if I will use 18 gram water have 6.022 into 10 raised to plus 23 atoms, then 250 gram of water have how many number of atoms? So based on the rule of 3, dear students, I can find the number of atom present inside this 250 gram of water. You get the point? So please be careful, because this is the game of numbers and you have to play with it. So be careful while playing with it, because if you made a mistake, your entire problem will gone. So dear student, now I can calculate that 250 multiply by 6.022 into 20 is to 23, 10 is to power of 23, then divide by 18 gram. So the number of atom will be, if I'll do the calculation, 83.64 into 10 raised to 23 will be the atom present inside that 250 gram of cup of water. So here I have the value which gives me the number of atom present inside that 250 gram of water. Now, dear students, we have to find out the charge. So as per uh, the quantization of charge, Q is equal to plus or minus Ne, we can find the charge present inside that 250 gram of water. So first we have to find out the charge of one H2O molecule. So I have already calculated the charge present inside one molecule of H2O. So look at here, please uh, stay focused because this is very important part of the problem. So the charge on the H2O can be calculated as Q is equal to, there are two hydrogen atoms. So the atomic mass number, sorry, atomic number, yeah, atomic number of hydrogen is 1. So there are one proton and one electron is present. That's why plus or minus E. So 2 into plus or minus E. Then if we talk about oxygen, oxygen have a atomic mass, atomic number is 8. So 8 proton, 8 electron. That's why 8 plus or minus E will be present. If you calculate this, we have a 10 plus or minus E. E is the charge. The value of the E is 1.6 into 10 raised to minus 19. So 10 into plus or minus 1.6 into 10 raised to minus 19. This is coulomb because that is charge. So Q is equal to plus or minus, if we calculate this, 1.6 into 10 raised to minus 18 coulomb. So dear students, now we have the charge of one H2O molecule or H2O atom. If we have to find out the total charge of 250 gram, then we can use, therefore Q is equal to, the value present here is 83.64 into 10 raised to 3 multiply by plus or minus of one molecule of H2O. It means this value. So plus or minus 1.6 into 10 raised to minus 18 coulomb. So dear students, if we calculate this, we will have 133.82 into 10 raised to 5. Okay. So now can I write like this? Q is equal to 1.34 into 10 raised to, if I will go left hand side, I have to increase the value by 2. Fine. So it will be 7 coulomb. So dear students, this is the charge present. And yeah, I have just forgot to write out plus or minus because both are present here. Plus or minus 1.34 into 10 raised to of power 7 coulomb. So if you understand my technique, my way of teaching, please do subscribe the channel. If you have a problem, write me in the comment. I will try to reply you. So now we will meet in next lecture. Till, be focused, do your studies and be safe.